Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora, and in this video we are going to solve exercise 2.2 from NCERT. Now since we have discussed all the important things in the previous two videos, we are directly going to solve question number 1. It says find the zeros of the quadratic polynomials and verify the relationship between the zeros and the coefficients. We had learned in the introduction video how to do this. Now, I'm starting with finding the zeros of this polynomial. I had told you, you can assume these polynomials as fx or px. Let us say px is equal to x square minus 2x minus 8. So for zeros, you have to mention that since you are going to find zeros, that is why you are equating this polynomial to zeros. By the definition of zero, we know that the value of the variable for which the polynomial becomes zero is called zero or root. So that is why I am making this polynomial equal to zero. Then we have this quadratic polynomial. Right? This is a quadratic polynomial. Before starting to find zeros, we need to check whether it is in the standard notation or not. Means it should be ax square plus bx plus c. We should have x term in the middle. X square at the first, x in the middle, and constant at the last. So this expression is in the standard form. So we now start doing middle term split. You have to first multiply. Here you have 1. Multiply 1 with minus 8. So we have minus 8 here. You have to look for the product of two numbers as minus 8. And the sum should be negative 2. This is, the product is negative. Product is negative, that means when you break this number into two factors, one of them will be positive and the other of them will be negative. Since we have a negative product, so we have to look for two numbers, one positive and one negative, right? Now, second thing is confirmed from here. See, the sum is a negative number. Sum is a negative number means when we take the sum of two integers like minus 5 added to 8, we take the difference and the sign of the positive number is assigned to this. Why? Because 8 is the bigger number. So when we take the sum of a positive and a negative number, we always get the sign of the bigger number in the answer. If the sign is negative, that means the larger number has to be negative. So I break down the factors of 8 first, like 1 into 8, 2 into 4. And there are no other pairs which make 8, right? So 8 into 1 is 8. I require negative 8 as a product, right? And by this thing, I'm explaining you again. The sum of the two numbers is negative. Either of the numbers is positive and negative. And since the sum is negative, that means the larger number has to be negative. So I'm keeping larger numbers negative here. The product is negative 8, product is negative 8. Now I do the addition part. 1 added to negative 8 is negative 7. 2 added to negative 4 gives you negative 2. Right? So this is our pair, which gives negative 8 as a product and negative 2 as the sum. So our requirements are satisfied by this pair. Now I am going to factorize this polynomial. X square negative 2 can be written as positive 2x negative 4x, or it can be written as negative 4x positive 2x later. It will give the same result in both the cases. So this is our factorization. Now we have these first two terms and next two terms, right? We have to take common from the first two terms, that is x is common. So after taking x, we have got x at the first place, and from here we are left with 2. Now since the third term is negative, I am taking negative sign common. And then from the third and fourth term, we have 4 as a common factor to both the terms. There is no x common to both, so only negative 4. So after that, I am taking x. We are left with x at the first place, and both of the term becomes positive. Since we have taken minus sign common, after taking minus common, when we are winding up this bracket, all the terms get their signs changed. So we have positive x and positive 2, right? Then after this factorization, we have got two terms in which x plus 2 bracket is common to both the terms. Then we are left with x minus 4 is equal to 0. Right? This was the factorization part. And now since these two factors are equal to 0, the product of two factors is equal to 0. That means either of them have to be 0. Like x plus 2 is equal to 0 or x minus 4 is equal to 0. So we get x is equal to negative 2 or x is equal to positive 4. Right? So this is the first part of solving for two zeros. Right? Next we have to verify the relationship of these two zeros with the coefficient of the polynomial. Right? So we can assume either of them as alpha and the other one as beta. Now we will solve the verification part. See, let alpha is equal to negative 2 and beta is equal to positive 4. Doesn't matter if you take vice versa. So now sum of zeros is equal to alpha plus beta. In that case, you have negative 2 plus 4. What is that equal to? That is equal to 2. Now see, can it be written as minus b over a? What is minus b? B is negative 2. Your a is 1, b is negative 2 and c is negative 8. So the sum of the two zeros is positive 2. It is written as minus 2 over 1. You can see it has to be minus b by a. So I have put minus here. What is the value of b? B is minus 2. Minus 2 is b. So minus of minus 2 over 1. 1 is the coefficient of x square, which is a. So I can say that it can be written as minus b by a. This is minus sign. Negative 2 is equal to b and a is equal to 1. So we have verified that our relationship of sum of zeros can be expressed as minus b by a, which was required, which is minus of coefficient of x over coefficient of x square. Right? The first part has been verified. Now we go for product of zeros. Product of zeros. That is equal to alpha times beta. Alpha here is negative 2 multiplied by positive 4, which is equal to minus 8. Minus 8 can be written as minus 8 over 1. Minus 8 over 1, what is minus 8? Minus 8 represents C and 1 represents A. So we can write negative 8 as negative 8 by 1, which is equal to C by A. And we can say this is equal to the constant part or the constant term over coefficient of x square. Right? So this was required in this question, and the further questions also we have to find the zeros first and then do the verification of these zeros with the coefficients of the polynomial. Second part is 4s square minus 4s plus 1. Now this is also in the standard form, ax square plus bx plus c. Now for zeros, I equate 4s square minus 4s plus 1 is equal to 0. Right? Now we are going to do the middle term split. That means we have to multiply the first term and the third term. So we have 4s square multiplied by 1 is 4s square. We have a positive product. Positive product means both the numbers are positive or both the numbers are negative. So here we have negative sum. That means the factors have to be negative so that we get negative sum. 4s square. Now the factorization for 4 is 1 times 4 or 2 times 2. So as I told you, both the factors have to be negative so that the sum is negative. So I take them negative. We get minus 5 here and minus 4 here. So this is the exact factorization that is required. Now breaking this middle term into 2, I write this as negative 2s and negative 2s plus 1. Now I take common from first two terms and common from next two terms. Here 4 and 2 have a common factor 2. We have s to the power 2 and s. So we have 1s common. Now 4 divided by 2, this gives you 2 here and 1s is left. From here, this whole 2s has been taken out. So we are left with negative 1. Now you can see that in the third and fourth term, first of all, this is negative. So I have to take this as negative. Moreover, 2 and 1 have only one common factor, which is 1. This has got 1s and no s here. So we cannot take anything common except negative 1. Since I have taken negative 1, so the signs of both the terms get changed when I close this bracket. This 2s becomes positive and 1 becomes negative. You can see that we always get these brackets same in both the terms. So now these two brackets are same, so I'm taking them common. After that, we are left with 2s minus 1 again. So this is a repeating factor. This is a perfect square, whole square. Since I have been taking middle term split method here, that is why I haven't used squaring method here. For zeros, you can say 2s minus 1 is equal to 0 and also 2s minus 1 is equal to 0. So we get s is equal to 1 by 2. S is equal to 1 by 2. Since this is a whole square, so we have repeating factors. This is a quadratic polynomial. It will always have two zeros. They may be distinct or they may be alike. In this case, they are alike. So now we come to verification part. First of all, for the sum of zeros is equal to alpha plus beta, which is equal to half plus half. 1 by 2 plus 1 by 2 is equal to 2 by 2, that is 1. Right? Now, see, 1 is equal to negative of negative 4 by, I'm trying to express this 1 in a distinct manner. That means it can be expressed as minus b by a. So check, this is minus. At b, we have b is negative 4, a is 4 and c is 1. So I have just put negative 4. That means this minus sign is for the formula, and at the place of b, we have negative 4. At the place of a, we have 4. So you can see minus minus 4 is plus 4 divided by plus 4 is plus 1. So 1 can be written as the ratio of minus b by a, which is negative of coefficient of x over coefficient of x squared. This is verified. Now we have product of zeros. Product of zeros is equal to alpha into beta. Alpha into beta. So now that is equal to half into half, which is equal to 1 by 4. 1 by 4. Now this has to be written as C by A. What is C here? C is 1. See, we can see. So at the place of 1, this is equivalent to C, and 4, A is equivalent to 4. So I can write this as C by A. C by A. So that means this can be written as constant term over coefficient of x square. We have expressed the product of zeros as C by A. That means constant over coefficient of x square. So we have verified that the product of zeros is equal to C by A. Now we come to the next question. This is our third quadratic polynomial. Now you can see by looking at this is not in the standard form, right? Here we have ax square. It should be ax square plus bx plus c. But here we do not have x in the middle term. It is in the last term. So I'm rearranging 6x square. Sign remains same. This has negative 7x. So I write it this. Negative 3 goes at the back. Now this is the standard form of this polynomial. Please do not forget to arrange it. Otherwise you will get confused why you're not getting the right zeros, right? So now this is a polynomial. Now I am equating it for zeros. For zeros, px is equal to 0. So 6x square minus 7x minus 3 is equal to 0. So I'm taking the product of first and third numbers. That means it is 6 into negative 3, which is negative 18, right? Now negative 18. Product is negative, so one of the factor will be positive and the other will be negative. Now look at the sum. Since the sum part is negative, the larger number has to be negative 1. So I make the factors for 18. It is 1 into 18, 2 into 9, 3 into 6. Yes, we can have only these 3 factorizations. So you can see for sum to be negative, I have to keep the larger number negative. I'm doing that in all the cases, right? Now let us check. The product in all the cases is negative 18, right? And the sum of 1 and minus 18 is negative 17. 2 and negative 9 is negative 7. 3 and negative 6 is negative 3. So you can see you require negative 7 as the sum. This is negative 7. The product is negative 18 in all the cases, but the sum has to be confirmed. So we get 2 and minus 9 as the factors. Right? Now I am splitting the middle term. This is 6x square. I can write this as positive 2 and negative x. So we get the product negative 18 and the sum negative 7. Right? And next we have to factorize these two parts separately. On the first part, we have two terms. 6 and 2 have a common factor 2. Here we have 2x and 1x. 1x can be taken as common. So after that, we are left with 3x. And at the second place, we have only 1. Now again, we can see that the third term is negative. So I am taking minus sign outside. In the third and fourth term, 3 is a common factor. So I am taking 3. After that, since I have taken minus sign outside, the signs of both the terms get changed. After taking 3, 3 is left at the third place, and x is there, and 1 is there. And both the terms become positive because I have taken minus outside. Right? So we have 3x plus 1 bracket common to both the terms now. And after that, we are left with 2x minus 3. Equating this to zeros, we get our zeros as x is equal to minus 1 over 3 and x is equal to 3 over 2. In the next question, we have t square minus 15. So this is our quadratic polynomial, but we have only two terms here. So I can write this in terms of standard polynomial. So this becomes at square plus bt plus c. So we can see that we have t square term here. So the coefficient is 1. A is equal to 1. And since we are missing the t term here, so we can say that b is equal to 0. And the constant term here is negative 15. So c is negative 15. Right? Comparing this with the actual standard form of the polynomial, we can see that a is 1, b is 0, c is minus 15. Now we come to find zeros. For zeros, f of t has to be equal to 0, which gives us t square minus 15 is equal to 0. We can see that 15 is, either we can take 15 to that side, or we can also write this as t square minus 15 can be written as square root of 15, right? So this becomes a square minus b square type of polynomial. This is quadratic, but it resembles to a square minus b square form. You can write this as a plus b, a minus b. We know the formula. A square minus b square is equal to a plus b into a minus b. So we have t plus square root of 15 multiplied by t minus square root of 15 is equal to 0. So now equating these two brackets individually to 0, I get t is equal to negative root 15 and t is equal to positive root 15. So these are the two zeros of this polynomial. So now we go for verification part. Verification, we can take either of them as alpha and the other one as beta. So verification means sum of zeros is equal to alpha plus beta. We have alpha as negative root 15, beta as positive root 15. The sum becomes 0, right? And this has to be expressed as minus b over a, minus b over a. So we can see in this polynomial the coefficient of t is missing. That means b is 0. So we can write this as negative of 0 over a can be taken as 1. Coefficient of t square is 1. So negative of 0 over 1 is 0 itself. So we can write this as minus b over a. Minus 0 by 1 is 0. So 0 can be written as minus b by a, which is equal to minus of coefficient of t over coefficient of t square. Right? Next we have product of zeros. Product of zeros. So for that we have alpha times beta. Alpha is negative root 15 and beta is positive root 15. So their product is equal to negative 15. Product is negative 15. So ideally it should be equal to c by a. So we can check our c here is negative 15. So I write this, my negative 15 can be written as negative 15 over 1, which is equal to c. Negative 15 corresponds to c and 1 corresponds to a. So we can see that product can also be written in c by a, which is equal to constant upon coefficient of t square. 1 is the coefficient of t square. So next, the last sum in this question is 3x square minus x minus 4. So now we can see that this is already in the standard notation. We can compare it this with ax square plus bx plus c, right? if you want, you can write it for your convenience that coefficient of x square is a is equal to 3. Coefficient of x is b, so b becomes minus 1 here. X is accompanied with minus 1 and constant term is negative 4. Now for zeros, p of x is equal to 0. Now I equate 3x square minus x minus 4 is equal to 0. We take the product of 3 and minus 4, right? The first term and the last term is 3 and minus 4. So we have product as negative 12x square. Product is negative. So we have one negative factor and one positive factor. Now check here for the sum. Sum is negative. So the larger one has to be negative. Now I factorize negative 12. First 12 is 1 times 12, 2 times 6, 3 times 4, right? And 4 times, sorry, it's enough. 4 times 3 or 3 times 4 mean the same thing. So we have these three factorizations for 12. Now, according to the sum, the larger one has to be negative. So I am keeping larger numbers negative. So in all the cases, the product remains negative 12. You can see one positive, one negative gives you negative 12. When it comes to the sum part, 1 and negative 12 gives you negative 11. And 2 and minus 6 gives you negative 4. 3 and negative 4 gives you negative 1. So this is the ideal factor which satisfies both the conditions for product as sum. So I am splitting the middle term here. Negative x can be written as positive 3x and negative 4x. So negative 4 is equal to 0. So these two and these two. Grouping these 4 terms into 2. So in the first 2 terms, we have 3x common. After that, after taking out 3x, we are left with x at the first place and 1 at the second place. From the next group, we have negative 4 common. Since minus sign is taken out, we are left with all the terms positive because both the terms are negative. 4 is common, so we are left with x at the first place. That is positive. And then we have positive 1 here, right? Now we can see that we have bracket of x plus 1 common to both the expressions. So x plus 1 is common. And after that, we have 3x minus 4 as another bracket. Equating them to 0, we get x is equal to minus 1 and x is equal to 4 by 3. So now we have found both the zeros for this quadratic polynomial. You can take either of them as alpha, the other one as beta, right? Now we come to the verification part. Verification. So for sum of zeros is equal to alpha plus beta, which is equal to minus 1 added to 4 by 3. The other one is this. So now we take the LCM of these two. So 3, this is negative 3 plus 4. The sum comes out to be 1 by 3. Now we have to show that we can write this as minus b over a. I put minus here. What is b? B is minus 1. So I write minus 1 inside the bracket. 3. 3 corresponds to a. Right? So we can see that this can be written as minus b. This is minus. B corresponds to minus 1 and this corresponds to 3 corresponds to a. So we can see that we have written 1 by 3, the sum of zeros as minus b by a, which is negative of coefficient of x over coefficient of x square. So next we have product of zeros. Product of zeros is equal to alpha times beta, which is equal to alpha is negative 1, beta is 4 by 3, which is equal to minus 4 by 3. Now see, what is C here? C is minus 4. You can replace minus 4 by C, and 3 can be written as A. So you can replace 3 by A, which is equal to constant part over coefficient of x squared. So this was our requirement, and we have verified both the parts. Right? This is very important question. You will be having one in your board exam from this exercise. Next question we have now. In this question, find a quadratic polynomial, each with the given numbers as the sum and product of its zeros respectively. See, we are given, see, in the order we have sum first and the product next. So in every case, the first number corresponds to the sum and the second number corresponds to the product of the zeros of the polynomial. And now we have to construct the polynomial. So how can we do that? See, the quadratic polynomial is represented in its standard form as this. So if we have to convert it, we have a simple formula for that. According to Ncert, you can do that. The polynomial is equal to, polynomial can be written as x square minus sum of roots times x plus product of roots. This is the simplest form in which you can make a quadratic polynomial if the sum of the zeros and the product of zeros are given to you. So in this case, we are in all the parts for this question, we are given the sum and the product of the zeros. We simply have to construct the polynomial. So we can do that by using this format. So in this case, the polynomial becomes, we can write this as fx or px. We can represent it by any function. So we have fx is equal to x square minus, this is a formula, you have to remember this. This is minus of sum of x. The sum here is, sum is 1 by 4 and the product is minus 1. So when you put here sum, it is 1 by 4 times x plus product. Product is minus 1. So in that case, your polynomial becomes x square minus x by 4 negative 1. Right? You can either leave it here or you can take the LCM and simplify it further. So this becomes 4x square minus x minus 4. And you can write this as 1 by 4 times 4x square minus x minus 4. So this is the quadratic polynomial that you have got. We have to perform same procedure in all the questions. So here we have the polynomial is equal to x square minus sum of roots multiplied by x plus product of roots. So in this case, you can write px is equal to x square. Here the sum is square root of 2 and the product is 1 by 3. So x square minus, at the place of sum, you can write square root of 2 multiplied by x plus product. Product is 1 by 3. So the polynomial becomes x square minus square root of 2x plus 1 by 3. Or you can simplify it further, in which you can take the LCM as 3. Then you have 3x square minus 3 times root 2 x plus 1. So you can write this as 1 by 3 in common. 3x square minus 3 root 2x plus 1. Fine. So the next sum says the sum is 0. Sum is 0 and the product is root 5. Sum is 0 and the product is square root of 5. So we simply put into the expression as, you can write here as q of x. x square minus sum of x plus product. So we have x square minus sum is 0. 0 times x plus product is root 5. So we get x square. This term becomes 0. So we have x square plus square root of 5 as our quadratic polynomial. Next we have sum as 1 and product as 1. Right? So now the polynomial, we can represent this as any, you can take this as u or this. So f of u is equal to u square minus sum of roots into u plus product of roots. You can use any variable, but the standard form should be the same. So here u square minus sum of roots. Sum of roots is 1. So I write here 1 accompanied with u. Product of roots is also 1. So the polynomial becomes u square minus u plus 1. Or you can make it with x also. It becomes x square minus x plus 1. Right? So the next is, in the next question we have sum as minus 1 by 4 and the product as 1 by 4. So here I'm taking this as q of x. So the format is x square minus sum of roots x plus product of roots. So I substitute the values here, minus accompanied with minus 1 by 4 x. Product is 1 by 4. So now we can do that. We can take 4 as the LCM. So we have 4x square plus 1x plus 1. So you can take 1 by 4 as a common factor outside, keeping all the terms in a bracket. Right? 4x square plus x plus 1 multiplied by this constant 1 by 4. So this is our polynomial. And the last question says the sum is given as 4 and the product is given as 1. So I can write p of y here. That means we have y square minus sum of roots multiplied by y plus product of roots. Right? So now substitute the values here. You can use any variable to form the quadratic equation. The format should be the same, that it has minus into the sum of roots with x or y, or the linear term should be the minus into sum of roots and the constant part should be the product of roots. So here minus s is minus of 4y, product is 1. When we open this, we get y square as minus 4y plus 1. So this is our polynomial which was required. So now we have finished our 2 exercises of the second chapter, which is polynomials. I hope everything is clear. If you have any doubt or any query regarding that, you can write me in the comment box. I definitely like to solve your problem. Thank you for watching my video, and please do not forget to share it with your friends. Please like, subscribe and share. Thank you.